Okay, there we are. So we did sine and cosine yesterday. Today we do sum and difference formula for tangent, and it looks like this. The tangent of angle A plus or minus B is equal to tangent of A plus or minus tangent of B. So the top looks just like you think it would look, but then there's a denominator, and it's 1 minus or plus the tangent of A times the tangent of B. So what do you notice that's interesting about this formula? Yeah, so the top one is going to be exactly like it is in the way you express it, and then the bottom switches. That's it. There's the formula. You ready to use it? Flip over the back side, we do two problems. The exact value, so when you see this on the test, again, I don't tell you you have to do sum and difference. You're going to have to look at the problem and say, oh, can I use a sum and difference formula in order to find this exact value? Well, first of all, you probably don't understand 19 pi over 12 as well as you might like, so let's change that into degrees. 19 pi over 12, we multiply that by 180 over pi. So that will turn into degrees. The pi's cancel. 180 divided by 12 is 15, and 15 times 19 is 285 degrees. So this problem changes to the tangent of 285 degrees. And my question to you is this. Do you know of two angles that either add to 285 or whose difference is 285, whose exact value of tangent you know? 135 and 150. That's the one we did last hour. First hour we chose 240 and 45. It doesn't really matter. I'm going to choose 150 and 135 because the math just happens to get a little bit messier and you encounter some problems like that on your homework. So we're going to rewrite this now as the tangent of, and you're going to want to conserve on space here. But we won't do anything down here, so if we have to push stuff down, you sure can. So the tangent of 135 plus 150. So I found two angles whose exact tangent value I know, and they sum to 285. So this becomes the tangent of 135 plus the tangent of 150 divided by 1 what? Minus, it switches, tangent of 135 times the tangent of 150. Now let's make our substitutions. What is the tangent of 135? Negative 1. What is the tangent of 150? What is the tangent of 135? We already said that that's negative 1. And 150 was negative root of 3 over 3. That's our fraction. So the trig is done, isn't it? Now it's algebra. Okay? Trig is done. Now we're doing algebra. The algebra causes some issues. We have negative 1 minus the root of 3 over 3 divided by, how many negatives do you have in the denominator? 3, so it's going to be subtraction, correct? 1 minus the root of 3 over 3. That is known as what kind of fraction? Complex, because you have multiple fractions in a fraction. Therefore, we try to write it as one fraction. One fraction at the top, one fraction at the bottom, and then we will multiply by the reciprocal. So, let's do that. How do I create a common denominator up top? Multiply by 3. So we have negative 3 over 3 minus the root of 3 over 3 divided by 3 over 3 minus the root of 3 over 3. I end up with negative 3 minus the root of 3 over 3 divided by 3 minus the root of 3 over 3. It's a lot of 3's. So I finally have one fraction at the top, one fraction at the bottom. What do I do? Multiply by the reciprocal. What do you notice? Leaves you with negative 3 minus the root of 3 over 3 minus the root of 3. Okay. Is that an acceptable answer? Why is that problematic? Because you have a root of 3 in the denominator, and you're not allowed to have a radical in the denominator. So we must rationalize the denominator. How do you rationalize the denominator? Do you remember? Close. If I multiply by the square root of 3 on bottom, I'll get 3, but then I'll get 3 roots of 3, so it won't entirely go away. What's that called? We change the ending. What's it called when you change the ending? Spanish. Yeah, we're going to multiply by the conjugate. Multiply by 3 plus the root of 3 over 3 plus the root of 3. And that will make the bottom simplify. So here we go. Let's do the top first. Negative 3 times 3. Negative 9. Then I get negative 3 times the root of 3 and negative root of 3 times 3. Then I'll have a combined total of negative 6 roots of 3. Then we do negative root of 3 times root of 3 gives me negative 3 over 3 times 3, 9. 3 times positive root of 3 and 3 times negative root of 3, those go away, which is why I multiplied by the conjugate. So now I have negative root of 3 times root of 3 is negative 3. Negative 9 minus 3. Minus 6 roots of 3 over, what's 9 minus 3? 6. Can you divide off of 6? Whoop. Careful with that. So you can see that the majority of our work, the trigonometry stopped here. That's where the trigonometry stopped. And you had algebra the rest of the way. And I know that algebra isn't always easy. There's different kind of levels of algebra that you encounter in different subjects. For example, some of the algebra you practice in calculus can get rather tricky as well. And a lot of times it involves working with large fractions, as you see here. So there you have it, negative 2 minus the root of 3. It'll be very important that I think that the sine and cosine problems probably worked out pretty well for you. These are a little bit trickier, so pay close attention to your tangent problems. Okay, we do one more. This one is a proof, and that might create anxiety for you, but trust me, it's much shorter and much less complicated than what we just did. What we just did was a lot more difficult. We want to prove that the tangent of pi over 2 minus some angle is equal to the cotangent of that angle. Yes. Sure. You could substitute theta for u if you'd like. Please do not write this down, but this does fit a difference formula for tangent. And so you might say, well, that's going to be tangent of pi over 2 minus the tangent of u divided by 1 minus, or I'm sorry, plus the tangent of pi over 2 times the tangent of u. And maybe we could simplify that, make that look like cotangent. But here's the problem. Look at your sheet. What's the tangent of pi over 2? Undefined. Well, if I get an undefined result here, that I can't get anywhere with this. So this is of no use to me. So I have to turn to another method, a different method. And here is that method. Tangent is the same as what? How can you rewrite tangent? Sine over cosine. So we're going to take the sine of pi over 2 minus u times, or divided by the cosine of pi over 2 minus u. That's the same thing as tangent of pi over 2 minus u. So I rewrote it like that. And watch what happens. It's really quite nice. Just get past this next step, and then it's really pretty. This is a difference formula for sine, isn't it? We learned that yesterday. We take the sine of pi over 2, and then what comes next in the formula? Cosine of u, and it's a minus, and then I do cosine of pi over 2, and I do sine of u. That's what you get when you do the formula we did yesterday. Divided by cosine, the cosine sum and difference formulas, it puts the cosines together, right? So it's cosine of pi over 2 times the cosine of u, and then it's plus the sine of pi over 2 sine of u. So all I did was I took our sum and difference formulas from the yesterday, and I wrote it out. Now, look at your sheet. What is the sine of pi over 2? It's 1. So I can replace that with 1. I can replace that with 1. What's the cosine of pi over 2? 0. So I can replace that with 0. I can replace that with 0. Look at what you get. What is 1 times the cosine of u? I get the cosine of u minus what's 0 times sine of u? 0. So you can see that whole thing goes away. 0 times cosine of u, that goes away. And 1 times sine of u gives me just sine of u. What's another way of writing cosine of u over sine of u? Now, did we know that cotangent was going to be the answer? Yeah, it said prove it. So we generally don't box the answer. There's a way that you try to indicate that you're done. So this is the fun part. When you're done with a proof, anytime it says prove, you can either say QED, which is Latin for something like quid edimus dominus. I don't know. I have no idea. Okay, but it's Latin. I know that, and it means that which was to be demonstrated has now been shown. Okay, that's what it means. It's great. You write it down, and then your parents come looking at your paper. You're like, oh, what's QED? And you're like, oh, it's Latin. It's really way too complicated for you to understand. You know, it makes you sound really smart. If you don't want to write QED, some people at the end, they put a little box. They just do a little box. It's kind of an indication that they're done, almost like a period or something. Some people put a box and they put a check in it. Some people do this. Now pay very close attention here. Some people write done. So you can choose how you want to end your proof. It can look real intelligent. You know, it's kind of like your signature. Some of my calculus students, they do all three just because they think it's funny. So. What? No, you can't. So, because I don't like it. So your assignment is 4, 5, and 8 were from yesterday. They were problems involved tangent. 14 and 15 should be pretty straightforward. 18 and 19 are proof problems, very similar to what we just did in class. Very similar. So that's all I got for you. I think we're out of here today at 1:20. So you have 18 minutes to work. All of you who missed class, we really missed you. And you missed out on special K-bars and Brent's birthday. So that's what you get for not showing up.